Okay, we'll start the class now. So today we'll see about interconnection standards. So we'll see what is interconnection standards. Computer, we know it has several ports, and what is the need of this port is we can connect our input or output devices through these ports. Okay, input output devices like mouse or a disk, external disk, anything we can connect with the help of this ports. And what about this standard? We are going to see the standard interfaces in this class. What is the standard interfaces? These standard interfaces, they have been developed to enable the I/O devices to have an interface with the processor. That is, we have to connect the processor and the I/O device with the help of the standard interfaces. Okay, we have three standard interfaces, that is PCI, SCSI, and USB. These are the three interfaces we are going to see in this class. And what is the use of this interface? It is used to enable the I/O device to use the interface to connect with the processor. So what is the purpose of it? To transfer the data between the processor and the I/O device. We need this. Okay, we'll see this PCI, SCSI, and USB one by one. PCI is nothing but it is a peripheral component interconnect bus. It is a bus and it is a low cost and processor independent bus. And so it is in the motherboard of the computer. It is housed, that is, it is mounted on the motherboard of a computer. And what is the use of it? It is used to connect the I/O interface for a variety of devices. Devices in the sense I/O devices. A device that is connected to this PCI bus, it appears that the processor directly accesses that I/O device. Okay, it appears like that. Okay, we are connecting through the PCI bus only. The processor and the I/O device will be connected with the help of a PCI bus, but it appears like the processor is directly connected to the I/O device. So we have we call this PCI as a bus. Yeah, so it is like a bus structure. We have a diagram for this PCI. So it is connected through the processor bus. We have a bus between this PCI and the processor, and that bus is called a controller. We call that as a PCI controller or a bridge. So between this I/O device and the processor, we have the PCI bus, and between the PCI bus and the processor, we have a controller. That we call that controller as a bridge. So the bridge, what it does is it has a special port for connecting the memory. We can connect the memory also. So for that purpose, we have this controller, that is bridge. So between the processor and the I/O device, we have the PCI, and between the PCI and the processor, we have a bridge, and this bridge, it helps us to transfer the data between the memory and the processor and the I/O device. So that is what here it is at the bridge. What it does is it translates and relays the commands and responses from one bus to other and transfer the data between them. So this is the actual PCI bus in a computer system. See, here we have a processor and we have a line called PCI bus. And this PCI bus is connected to several I/O devices. See, for example, the disk, printer, mouse, keyboard, everything is connected with the PCI bus. This PCI bus is connected with the processor with the help of a bridge, PCI bridge. This bridge connects the graphics interfaces and also the memory. Okay, so the bridge transfers the data between the processor and the I/O device. So the processor and the I/O device is connected through the PCI bus, and the bridge acts as a interface between the PCI bus and the processor. So here is the actual process we have. When the processor sends a read request to an I/O device, the bridge, what it does is it forwards the command and address to the PCI bus. Okay. So the processor, what it does, it wants to make a read request. That is, it wants to fetch the data from the I/O device. It will send a request to the bridge. The bridge, just like that, it forwards that command. A command in the sense read or write command. So read command for fetching the data from the input device, and write command for writing the data, that is displaying the data on the output device. That command and the address specifies which particular I/O device we are going to use to the PCI bus. Okay, so when the bridge receives the device response, so the processor makes a request to the bridge, and the bridge will send it to the I/O devices connected to it. and the address, particular address will be given. So each and every device have a unique address, and the device which have that address will respond to the bridge. So the bridge, when it receives the device's response, it forwards the data to the processor using the processor bus. So here the IO device, they are connected to the PCI bus through the ports. As I said, each and every computer will have several ports to connect the IO device. So how it connects? With the help of the Ethernet or USB or SCSI or SAS. There are several provisions are there. So using those provisions, we can connect the IO device with the PCI bus. So usually the data will not be sent one by one. Instead, a burst of data, that is a huge amount of data will be sent, will be transferred between the device and the processor. So here also the words stored in the successive memory locations are transferred directly between the memory and the IO device. So here a PCI, it has a bridge. Through the bridge, it can transfer the data from the IO device to the memory, and from the memory to the IO device. So from the memory, the processor can take. Like that, the bridge acts as a interconnection between the IO device, processor, and the memory. So the data transfer, how it happens is the data transfer are initiated by the interface of the IO device. So that interface will act as a master. Usually the master will initiate the transfer. So as I said, each and every word will not be sent one by one. Instead, a multiple word will be transferred at a time. So here the PCI bus, what it does is it will send the address and the data both in the same line. So previously we have seen address, we have a separate bus, and data we have a separate bus. But in this PCI bus, we have the same line to transfer the address and the data. So initially what it does is the bus master, which is a device that initiates the data transfer by issuing a read and write command. It is called a initiator. Okay, the addressed device that responds to these commands is called a target. Okay, so whatever maybe that is, if it is a processor or here we have a PCI. So the PCI, it will initiate the data transfer because the processor will send the command what it needs. That is, when it want to fetch the data, it will send a command to the PCI. The PCI, it will be acting as an initiator, and it will send it to the devices connected to it. The device which responds to that request is called a target. Okay, we have an initiator and a target. Initiator is the PCI and target is the IO device. We have several bus signals that are needed to make all these transactions. That is, that we have to send a request to the device, and also the device should respond. For all these things, we have some set of bus signals. So that are listed in the table that I'll show in the next slide. Okay, so we have a signal called target ready. So this target ready is equivalent to slave ready. That is target ready. Here the target is the IO device. So when the IO device is ready to transfer the data, it will provide a target ready signal. Okay, and we have a signal called IRDY. IRDY is initiator ready. Initiator here is the initially the initiator is a processor, but it will send all the requests to the PCI. So now the PCI is the initiator. So when a request is made, and when the device sends the data to the PCI bus, and when the PCI bus transfers the data to the memory or the processor, one complete transaction is done. The transfer of operation between the processor and the IO device, when it is completed, it is called a transaction. So we'll see how data will be transferred with the help of the clock. So here this is a table which specifies the signals needed. CLK is the clock signal. So here we are using 33 megahertz or 66 megahertz clock. Also we can use frame. It is the duration of the transmission of the data. So within this duration, we have to transmit the data. That is specified by the frame. AD is the address lines. Here we are going to use both the data and the address will be transferred in the same line. So we have this AD signal. AD signal, it is able to pass the address and the data. And the C bar BE. So this is a command, that is when you are going to give a read or write command, that should be specified in this command line. And byte enable lines. Byte enable, when the data is ready, then the byte will be enabled. And as I said, IRDY and TRDY, IRDY is the initiator ready and TRDY is the target ready signal. And device select, so we have several devices connected. So we have to select only one device at a time. So that device select is done by the signal DEV-SCL. And after selecting the device should be initiated. So for that we have the signal ID-SCL. So this is a signal to initiate the selected device.